In our last video, we discussed about what databases are supported on Azure. We looked into SQL Server data management via compression, and options around storing SQL Server data file in blob storage. Do you think your Azure setup is secure? Think again. Hackers, data breaches, and performance slowdown. They are waiting for one single weak spot. Is your Azure VM locked down? Is your blob storage truly secure? What about SQL Server and Oracle databases which you have in your landscape? One misstep and that could mean disaster. But don't worry, we have got a battle plan to keep your Azure environment secure and optimized. Let's expose the risk, fix the gaps, and supercharge our performance. Are you ready? Let's dive in. What do we have in store for today? We are tackling some of the most critical security and performance challenges in Azure. How secure is your Azure VM? Is your Azure blob storage truly protected? What is SQL Server TDE? What is SQL Server Buffer Pool extension? Running Oracle on Azure? What are the best practices? We'll talk about encryption, defense in depth, the best ways to lock down your virtual machines. This will help you understand very important topics for exam, since there will be questions around this. So be sure to watch this till the very end and not skip any part of the video. Let's dive in. Welcome back to AZ-120 SAP workloads on Azure series. In this series, we are laying the foundation for running SAP on Azure's IaaS platform. In this video, we will further dive into databases for SAP, specifically focusing on the security aspect. If you have not watched the previous videos, I would strongly suggest that you do that from the link in the description section. If you're new here, my name is Rajdeep. I'm a Microsoft certified trainer, a solution architect, helping clients building amazing solutions every day. And we are on a mission to make learning fun as well as crack certifications in that process. We all know that security is not a one-time thing. It's a mindset. In cybersecurity, this principle is called defense in depth. Think of it like securing a house. You don't just lock the front door. You install security cameras, set up alarms, and maybe even have a guard dog. In the cloud world, encryption is one of those crucial security layers. So what exactly is encryption? Why does it matter? Encryption is the process of converting readable data, plain text, into unreadable gibberish so that only authorized users can access it. Imagine scrambling an egg. Can you put it back together? No, right? Encryption works similarly, making the data unreadable to unauthorized user. But here's a fun fact. Encryption isn't new. It dates back to 1900 BC in ancient Egypt, where they used to use hieroglyphs. Now these hieroglyphs were altered to hide messages. Fast forward to World War II and we had the famous Enigma machine designed to encrypt military communication. And today encryption is everywhere, from securing your WhatsApp messages to protecting enterprise data in Azure. Now you might ask, how does this encryption work? Well, encryption works in two main ways. First method is called symmetric encryption, wherein a single key that locks and unlocks your data. The same key is used to encrypt and decrypt the data. Asymmetric encryption. Here's where things get interesting. Instead of one key, you have two keys, public and a private key. Public key is the one which encrypts the data. The private key decrypts the data. This ensures that even if someone intercepts the encrypted data, they can't decrypt it without your private key. Now that we have understood encryption, let us understand some concepts which will help us secure the Azure VM. Now let's take an analogy of our house again. The first step for securing a house is to set up security on the gate. In Azure, that's your network. Network security consists of network security groups or firewalls which you set up in the perimeter network. This would be your first line of defense against any kind of threat. You would also want to make sure important stuff like jewelry, documents, cash is secured in your house. So you would buy lockers and safe, which keeps the document, money, essential stuff secured. So Azure Virtual Machine supports Azure Disk Encryption. This uses BitLocker in Windows and DMCrypt in Linux to encrypt your disk. Now some organizations don't want Microsoft managing their encryption keys. Maybe you're working in a finance or a healthcare company where compliance is critical. The good news? Azure lets you use customer managed keys through Azure Key Vault. This means you control the keys, you decide when to rotate them, and you have full visibility into encryption operations. Now, Microsoft uses 256-bit AES encryption, which is one of the strongest encryption standards in the world. It is also FIPS 140/2 compliant, a security requirement used by government agencies. But here's the real kicker. You can't turn the encryption off. Now that we have secured your virtual machine, it's time for us to focus on Azure Blob Storage. First, let's talk about how you should deploy your storage account. You should use Azure Resource Manager templates. It's like a blueprint for your storage setup. Instead of manually creating resources, use infrastructure as code. You can use Terraform or Bicep templates for deployment. Organize your storage in resource groups, which act as logical container for easier management. Microsoft provides several best practices to keep your storage secure. Let's go through them in our Azure post.
In order to make this demo easier, I have already set up a storage account under this resource group. Here you can see the storage account. Now let's go ahead and enable Microsoft's Azure Defender. Defender is like installing a 24/7 security guard on your storage. So let us find Defender, Microsoft Defender for Cloud. In Microsoft Defender, we will go to the environment settings. Under the environment settings, let us find out the subscription where our resource is located, so which is this one. And in Defender plans, you can find out various resources which you can secure using Defender. So for our case, we will be using the storage. So let's turn it on, and then you can fine tune it by clicking on the settings. You can do a malware scanning, a sensitive data discovery, so on and so forth. If you save this, it will start defending your storage account. Now you can see the cost. It's like $10 per storage account per month. Now imagine you have a very important file in your storage account and by mistake you delete that file. Soft delete is a feature in storage account which keeps your deleted blobs in recycle bin for 1 to 7 days before permanent removal. How do we enable that? We go to data management in storage account, and then we go to data protection. Under data protection, you will find an option enable soft delete for blobs, for containers. If you look at the text, soft delete enables you to recover the blob that were previously marked for deletion. So in order to enable this, we can just click on this and we can specify the number of days where you want to keep those soft deleted data. So let's say 30 days, and I'll do that for the containers as well. 30 days and save, and it's done. Now sometimes you will get into a situation where not only the blobs but the complete storage account is being deleted. You kind of want to put a child lock on it that even if somebody has access, they cannot delete the storage account or change any storage settings. On the left hand menu, we will go to the settings and you will find a locks option. Click on that and then you can add a lock to that. Let us name this lock str lock. Lock type, we can specify, is it only a read-only lock or a delete lock? Let us put a delete lock and let us give it a name, cannot delete. Click OK and voila, you have your lock enabled. Now nobody can delete the storage account. Let us try to go ahead and delete the storage account and see if it actually works. Click on it, delete. It has failed. So error says str mount scope locked, which means it will not allow you to delete the storage account. Now another scenario is you might have some critical files on your blob storage which cannot be modified or deleted till a set period of time. You can set a time of your own liking or put a legal hold on it, like writing contracts and permanenting. Let's see how we can enable that. In the left hand menu, we will go to containers and we will create a new container, say immutable. Create it. We can click on this container properties and the access policy. You can add a policy. So you can see a policy type which is already created by Microsoft is legal hold or time-based retention. So basically, if you put a legal hold, this particular blob cannot be deleted. You can also set a time-based retention, which means you can specify that there is a specific period of time, say 30 days. Till that time, the blob data cannot be deleted. Let us put a retention of time-based. Now you see access policy has been enabled. You want all the data which is transferred from your blob to be via a secure channel. So this property is called require HTTPS. You might know that there is a S in HTTPS which stands for secure. Now this S encrypts the data in transit, preventing attackers and hackers from eavesdropping on your files being uploaded or downloaded. So how do we enable that? We go on the settings, under configuration, there is an option which says secure transfer required. So if you click on the I button, it will tell us the secure transfer option enhances security of your storage account by only allowing requests to the storage account by secure connections. So if you click on enable, only HTTPS requests will be allowed into the storage account. There is something called as SAS in the storage account. This SAS is basically a shared access signature. It's a URL that grants restricted access to Azure Storage Account resources. Now you want the SAS to be HTTPS only. You go to the securities and networking. Under shared access signature, we'll find out allowed protocols, and here you can see it's already enabled to HTTPS only. If we click on HTTPS and HTTP, it will allow both secured and non-secured communication. So let us keep it under HTTPS. Now that you have secured this data inside your storage account, let's make sure that only right people have access to the data. How do we do that? Some of the recommendations from Microsoft is use Microsoft Entra, erstwhile Azure AD, to authorize access to blob data, and follow the principle of least privilege. What does that mean? Only give access to those who absolutely need it, nothing more. So we can find that setting under configuration, and under configuration you will find default to Microsoft Entra authorization in Azure portal. If I click on enable this one, then any access to the data will be via Entra. So you can control who has access to the storage account and subsequently the data inside the storage account. Now the shared access signature can also be used to grant temporary access. It's like a car valet key that only starts the engine, but you cannot open the trunk. You can regenerate the keys periodically. It's like replacing the locks every few months in your house. So if you go to the security and networking, there are access keys. You can store these access keys in another resource which is called Azure Key Vault. You can also generate these keys again, like rotating them. If you rotate them, the keys will get regenerated instantly. If you feel that someone has tried to access the storage account, you can change the storage account keys immediately. This is like resetting your password. So now you have encrypted your data to the storage account. You have restricted who has access to the data. You would also like to restrict the storage account from being accessed via the network. So how do you do that? The first thing you should do is the minimum TLS version. The minimum TLS version which you should select is the latest one, which is version 1.2. Under configurations, you will find this setting. So select that and click on save. So what does this TLS do? This TLS ensures that clients use a strong encryption when they connect to the storage account. On the networking part, we can also enable firewall rules. So as you can see under networking, right now the public network access is enabled, which means all public networks can now access the storage account. You might want to restrict that and click on it and click on disable. So once you click on disable, it will not allow any public network to access the storage account. So which means you are blocking all public network access. You can also set the routing preference as to what kind of routing you would like to prefer. So if you set it as Microsoft routing, then Microsoft will take care of the routing. Another point which you can enable is called private endpoint. Now private endpoint is like creating a private connection to any virtual network which you might have inside your Azure environment. So in how do you do that? You need to give it a name, private endpoint name, and it'll create a NIC. So this NIC interestingly gets created in the virtual network to which you want to connect to. Storage account is, as you know, is a PaaS service, and we are creating a private connection from that virtual network to this storage account. Now in order to create this, you would need to provide the virtual network. Now the main gate is secured, your data is secured, access to the data is secured, perimeter is secured. Now you would like to install a CCTV camera in your front gate. You want to monitor who gets in, gets out, what is going on in the house, what is going on outside the house. So in order to do that, you can set up monitoring on your storage account. You can go to the diagnostic settings under your storage account, select your blob and add a diagnostic setting to it. Give it a name, diag1, and then you can start collecting logs. So say I want to collect all logs, I want to collect storage, read, write, delete, everything. And also I want to collect the transaction logs. And then you can also select the destination details here. You can select to send the logs to log analytics. You can also send it to a storage account. You can also stream it to an event hub and also send this to a partner solution. Say you do not want to use Azure Monitor, you can also send this data to a partner service. So now your storage account is fully secured. You have encrypted the data. You have set up security in the perimeter. You have also restricted who has access to data. On top of that, you have enabled monitoring so that you know who gets in, gets out, and what exactly he does on the storage account.
Well, as per our defense on depth principle, which we discussed earlier, let's understand what we can do in the SQL Server in order to secure the database data from hackers. Because remember, data is the beating heart of the organization. Now, SQL Server provides a very good feature which is called Transparent Data Encryption. Transparent Data Encryption, also known as TDE, will encrypt the entire database, including backups and even transaction log files. This may help you when you need to meet some of the regulatory requirements or compliance requirements. And TDE will help you to achieve that as well. It performs a real-time encryption and decryption, so you might not realize that this is happening in the background, hence very minimal impact on the performance. Now let's put the lens of SAP and understand TDE. Is TDE supported by SAP? Absolutely yes. What factors should you consider if you're migrating, say, from another database running on-premises into Windows SQL Server running on Azure? Let's understand this with our house analogy. Say you have built a new house. Then you move in your furnitures inside the house, your money, and other precious things like jewelry and documents. After that, you start encrypting, aka installing alarm, locks, and security camera. Problem: you are stuck guarding the door while each worker installs locks and alarms. This will slow down the process. In database terms, this will translate into downtime. However, the second approach is install all the locks and alarms and then move in your furniture into the secured house. Result: security is baked in during moving in. There's no extra waiting, so less downtime in the database terms. So let's explore this step by step. Create a blank SQL Server DB, install security locks, aka encryption, enable TDE in the empty database. Since there is no data to encrypt, the process will finish fast. Test your connection to the SAP systems, and now stop the SAP system and move in your furniture or export your database into SQL. However, there are some considerations which you need to keep in mind when you are enabling TDE setup for your SQL. What are those considerations? You do not have the control on the number of threads or SQL worker threads who will work on applying encryption on the database. Now, SQL will automatically assign threads based on the number of volumes, and at any time they can only work 64 KB chunk of data, which means more the number of volumes, more threads will be used for encryption. Solution: reduce the number of disks in Azure Virtual Machine. A note: each disk encrypted is then written on the transaction log file of SQL Server. The more the number of disks, more pressure on the transaction log. Possible solution: perform encryption in an off-peak hour. Consider giving some extra juice to your infrastructure when TDE is being applied, and post that you can shrink the infrastructure to an optimal cost-effective. With TDE, your SQL Server database, backups, logs are fully encrypted, ensuring regulatory compliance, protection from unauthorized access, and minimal performance impact. Now, we talked about securing the database and we also talked about securing the blob storage. Let's also understand one interesting feature is called Buffer Pool Extension. Buffer Pool Extension is a feature introduced in SQL 2014 that aims to improve the database performance by expanding the buffer pool beyond its physical RAM. So, what is buffer pool? Buffer pool is the SQL Server's memory area where it caches frequently accessed data pages. When SQL Server needs to read or write data, it first checks buffer pool to see if the required pages are already in the memory. This reduces the need for slow disk I/O operations. Let's understand this with an analogy. Imagine that you are running a massive library. Most borrowed books are kept in the front rack for quick access, with older or less frequently used books are in the storage room. Now, what if your front racks get full? You have two choices. Expand the front rack, which is add more RAM, but that's expensive, or introduce a middle tier bookshelf SSD as a cache, storing frequently used but less critical books. You might remember in our previous videos, we understood a similar concept called NSE, Native Storage Extension. Check out this video in the description section to know more about it. To refresh your memory, SAP HANA uses NSE or Native Storage Extension to move warm data to disk while keeping hot data in the RAM. Similarly, BPE allows SQL Server to use solid-state drives as an extension of its buffer pool. It's like a two-tier cache. Level 1 is the physical RAM and level 2 is the SSD. BPE is great when your workload exceeds your RAM, but for high-performance environments like Azure, there's a better solution. Instead of BPE, Microsoft recommends use Azure Premium Storage with read-only caching for SQL Server data files. This approach leverages built-in optimizations in Azure and simplifies management and improves performance better than BPE. Just like SQL Server, Oracle also needs the right configuration to ensure performance, reliability, and security. If not set up properly, you may face slow performance or even data loss. Let's go over SAP's key recommendations for running Oracle on Azure so you can get the best performance and security. Install Oracle database on a separate disk, meaning keeping database files separate prevents performance bottlenecks and improves reliability. However, Oracle data and log files must be on a separate disk for optimal performance. Separate data and log files. Database files, redo log files must be stored in separate disks to prevent performance bottlenecks. SAP recommends placing temporary table space files on D drive, which is our non-persistent drive, because D drive offers better performance for temporary database operations. File system support, only single instance Oracle using NTFS file system is supported. All database files must be stored on NTFS, preferably on Azure Managed Disk with Premium SSD storage. Also, it is advised not to use any network-based storage for Oracle database files like Azure File Services. Network drives are not supported and they can introduce latency and data consistency issues. By following these best practices, you will ensure that your SAP on Oracle runs efficiently in Azure. Wow, we covered a lot today. Securing your Azure VMs, storage accounts, and databases, plus boosting performance with SQL Server BPE. So what's the key takeaway? Security and performance go hand in hand. But now I want to hear from you. If you found this helpful, hit that like button, subscribe for more deep dives, and share this with your friends so you and your friends and your colleagues can stay ahead. Until next time, stay secure, stay optimized, and keep innovating.